Welcome back to the today's part of the session. In the previous class, let us take up on the topic related to the reaction kinetics. In this today's part of the topic, let us discuss what the basic terminologies involved, what we call it as a reaction, and what is meant by the term kinetics it refers to. Normally, you need to understand the term reactions. It involves combination or separation of any chemical compounds. And what does the kinetics it refers to? The kinetics, it mainly refers to how fast the rate of the reaction, that means what is the term, maybe if I consider A is the reactant giving rise to the product, okay. You might have come across in the chemistry related to the chemical kinetics. This is a repetition manner, but the applications are very much important when you come across in the case of the designing considerations of the wastewater treatment. Consider A is a reactant having some concentration, maybe a compound leading to the formation of the B. For example, it may be related to the formations of the water. It may be leading to the formation of H plus ions and OH minus ions. Simple. Getting it? And here the type of the reactions involved, we call it as A giving rise to B. It is only a reversible type of the reaction. Sorry, irreversible type of the reaction. Irreversible reaction. And this kind of the reactions where the change is taking place or the equilibrium shift either towards the left or to the right, that kind of the reactions can be determined through the kinetic equations. Hence, we call it as reversible reactions. Reversible reactions. Now, how fast the process takes place? What are those processes and all? In the water supply and treatment engineering, you might have come across aeration process, okay, addition of a disinfectant or a chlorine, or maybe even in the case of the coagulation and coagulation and flocculation process, mainly leading to the precipitation one. Okay, in this particular instances only we come across to categorize how does the reactions takes place, and mainly what is meant by the reaction or what is meant by the kinetics. Kinetics, they mainly refers to the rate at which the reactants are converted in terms of end products and what is the time required. If I have some set of a concentration for the A and the time taken for converting the product from the concentration A to the B, how much time is required? This is the major thing we need to adopt or imply in the case of the wastewater treatment systems. Is it not you have come across the jar test apparatus? How much time is allocated for the optimum dosage of the coagulant and to reduce the turbidity? In this manner only, in order to reduce the obnoxious or the odor gases caused by the iron or the manganese, you need to apply the air or maybe introducing the air into water or water in terms of an air. That process we call it as an aeration process. All these things we come across as a kinetic reaction. For example, if you have not yet understood, whatever the food that you have prepared in your home and all, if you keep it for a 24-hour period, some of the food they tend to rotten or decay. That kind of the matters we call it as a non-conservative substances or non-conservative matter. The kinetics, that means if any of the compounds, it does not changes with respect to the time, the concentration remains same as it is itself only, that kind of the substances or the matter, we call it as a conservative substances. The reaction kinetics is not only the chemical related or the chemical oriented type, it is also relatively to the biological oriented reaction also. Maybe the BOD or the COD exertion, how does the decay, for example, decay of the trees or the dead portion of the animals and all, it has to take place. It is in part of a natural cycle itself only. If decay would have not taken place, and we have to survive with respect to the foul odors itself only, things that are surrounding us. So, certain instances we come across where the decay has taken place, either it may be a fast degradation rate or maybe a slow degradation rate or even maybe the moderate degradation. That kind where the reactants are converted in terms of a product, we call it as a kinetics. It is mainly represented with respect to the rate of change of concentration is directly proportional to the concentration of the substances rise to the stoichiometric coefficients. It is mainly defined with respect to the law of the mass action. Okay, keep it in the mind. It is mainly related to the law of mass action. And what are the types of the reactions that you come across? Two principal types of the reactions mainly occurs in the case of the wastewater treatment process. There are two types of the reactions. One is homogeneous reaction. One is homogeneous reaction. Second one is heterogeneous reaction. Heterogeneous reaction. What is the term homogeneous reaction? It mainly refers to homogeneous reactions. They are mainly occurring in the fluid condition, and this particular sorts of the substances mainly takes place while a single reactant giving rise to a single product. No any other subproducts are formed. That we call it as a homogeneous type of the reaction. Then in that homogeneous type of the reactions, what are the type of the reactions that is taking place? See, example is water itself only. That is the chemical displacement reactions or chemical combination and then acid base kind of the reactions. These are the different set of the chemical reactions that we come across in the chemical analytics, also in the physical chemistry part. This physical chemistry part is very much important in the case of the analysis in the any of the environmental impact assessment or maybe even in the case of the wastewater treatment and reclamation also. Getting the point clear for this? And normally the simple reactions is given as A giving rise to the product or maybe A plus A giving rise to some other conditions. Okay, the some other conditions it is mainly the C, or the concentration AA plus again the next set of the concentration we call it as B into B giving rise to C. So therefore, if you need, this is the part where we come across for the expression related to the reaction kinetics or the coefficients. Getting the point clear with respect to this? And there are such type of the reactions we call it as parallel reactions, and then consecutive reactions. Parallel reactions as well as consecutive reactions. What is meant by a parallel reactions? Maybe two set of the series of the reactions that takes place, that we call it as a parallel reactions. Consecutive reactions means reactions that tends to go A plus B giving rise to C, again this C will undergo further reaction. Okay, A plus C is giving rise to D. This kind of the reactions we call it as a consecutive reactions. What about in the case of the parallel reactions? A plus B giving rise to C as well as A plus B giving rise to D. This kind of the reactions we call it as a parallel type of the reactions. Therefore, these are the set of the conditions we need to come across or to check in the case of the wastewater treatment. Either maybe the trickling filters that you are going to use, or maybe activated sludge process, or mainly related to this set of the categories. Okay. I hope you have understood the concepts related to the homogeneous type of the reactions. What is meant by heterogeneous type of the reactions? How does it takes place? What are the systematic part of an expression related to the kinetics? That kind of all the things let us get to know in the next part of the class. Hello everyone, welcome back to the session once again into the chemical kinetics of wastewater treatment. In the previous part of the class, you have come across the concepts related to what are the terms, mainly the term reaction and what is the term kinetics it refers to, what are the different phenomena that tend to occur. Maybe a parallel type of the reaction, consecutive type of the reaction, homogeneous type of the reactions and heterogeneous type of the reactions. I need to explain it. Now let me take upon for the heterogeneous type of the reaction and let us get to know what are the different expressions that are used to determine the rate constant or maybe the rate which is either a first order or a second order or maybe a third order type of the reaction. Let us get to know one by one in today's part of the topic. Mainly the reaction kinetics, it refers to the set of the reactions, Earlier I have stated either may be a moderately degradable, slowly degradable or maybe a rapidly degradable type of the constituents that are present. Now heterogeneous type of the reactions and homogeneous type of the reactions are another two set of the reactions that takes place. One is a homogeneous and heterogeneous. Same kind of the reactions that are being involved, we call it as a homogeneous type of the reactions. Whereas in the case of the homogeneous reactions, they are uniformly throughout the fluid system, they are uniform. Whereas a heterogeneous system, they are non-uniformly occurring in nature and it is much more complex. Okay, they are non-uniform and quite complex in nature. What is the term heterogeneous? It mainly it refers to the series of the chemical reaction taking place in a different medium. Either it may be a air-water interface or we call it as a gas-fluid interface. Either maybe the fluid to solid interface or maybe the combination of the gas, fluid and solid interfaces. They are mainly characterized by the transport as well as the transformation. Transport as well as the transformation, where you can observe it clearly. Maybe in the case of the adsorption or the transport of the substances which are of non-uniform and they are of variety of the constituents, that the process taking place either continuous process or maybe in an intermittent manner. They have either in the case of interparticle transport in the presence of the catalyst as well as adsorption onto the surface sites. and even the adsorption taking place inside the reactor. Okay, these are all the categories where we come across to determining the transport as well as the transformation. And mainly transport of the products heterogeneous type of the reactions. Now moving on to the next part of the topic, what is meant by a rate of the reaction? Normally I would like to introduce you to the equation which is essential for you people. We call it as a mass balance equation. Mass balance equation. What is the mass balance equation? Always states that it is mainly related to the conservation of the mass or the concentration mainly it refers to the accumulation is equal to either to the rate of formation or maybe the loss. If you take any of the reaction, either maybe a coagulation or flocculation process, sedimentation type of the process, disinfection type of the process, each and every process involves some or the other sorts of the kinetic phenomena. All the processes are governed by the mass balance equation, mainly states that accumulation is equal to input into the system minus output from that of the system that is going on, and rate of reactions that is taking place either in the form of the sources or maybe the sinks. Now my part of an expression is how to determine what is the rate of reaction. Okay, let us get to take upon what is meant by rate of reaction. Rate of reaction is mainly expressed in terms of an conservation of the mass, as I have stated that if you take concentration is equal to mass by volume, okay, concentration is equal to mass by volume, which implies that if I wanted to determine what is the mass, so therefore mass is equal to concentration into volume. Okay, if you go for taking mass either maybe in terms of an kg or kilogram, or volume in terms of an liters, or if I take it in terms of a gram per liter, it is better for you people. You might have come across in the water quality standards also. Therefore, either in terms of an mg or maybe gram per liter. Therefore, if I wanted to get to know the mass, what happens here? Mainly, you take the concentration which is expressed in terms of grams per liter and multiply it by the liter, thereby leading to the formation of mass in terms of grams. How many grams have converted in terms of products? What is the rate of forward reaction and to that of the backward reaction are to be determined. Okay, this is mainly due to the changes or the transformation taking place. That transformation which taking place with respect to the time, we call it as a rate of reaction. Normally, the rate of reaction we call it as R is equal to 1 by V into derivative of the concentration. Derivative of the concentration. N is replaced by the term Vc, or what we call it as M. Okay. Now if I replace it here, what happens? 1 by V into d by dt of what is that mass is equal to concentration into volume. Now if volume is considered as a constant without changing under the isothermal condition where temperature is constant, isothermal condition, therefore volume can be taken outside, that is equal to 1 by V into dC by dt. Totally you will get it in terms of this. If at all, if not means apply the chain rule of the differentiation, C into dV by dt plus V into dC by dt. Same thing that come across for here, or derivative of Cv is equal to C into dV plus V into dC whole thing divided by here the concentration expressed in terms of in moles, okay, and the volume and time also. This is the one particular set of the category. Okay. So, fundamental part of an equation is much more essential. Why I am stating this kind of a mass balance equation means, in the upcoming module number 3 as well as in finding out any of the problems, you need to draft a solution which is mainly based upon the mass balance process itself only. That is why we have come across for deriving this set of an equation. And if it is in terms of an positive, means accumulation is on increasing, R is equal to dC by dt, positive means accumulation, it always tends to increases. And if R is equal to minus dC by dt, accumulation tend to decrease. Accumulation tend to decrease. This is how the precipitation process, coagulation flocculation process, formation of the nitrate as well as nitrite, and from the nitrite to nitrate, or from nitrite to directly to the nitrogen gases, the inverse process that taking place is mainly based upon either the accumulation or maybe in terms of a decrease in the accumulation. Uptake of the nutrient by the plant, it is also governed by the kinetics. Similarly, the dissolved oxygen concentration as well as the temperature correction factors mainly depend upon the kinetic conditions. I hope so you have understood what is meant by this, where C is the concentration and M is mass of the substance or the material expressed in terms of this. Volume is equal to what and how it is expressed. So, V always represents the volume. Getting the point clear? This is how they go for deriving the mass balance or the material balance equation. There are lots of theories related to the mass balance equations. Certain steps are quietly complicated and that part of the derivation has not been mentioned in your syllabus. Okay. I hope so it is clear. Maybe in the disinfection kinetics, if you are going to take it, it is a first order equation. Whatever in the environmental case of an analysis, I think in the aeration process, same thing has applied there also, where you come across the liquid or the gas fluid interface. It is a heterogeneous in nature. Therefore, the kinetic phenomena changes. Okay. So, with this, let me take upon the type of the reactions or the order of the reactions. So, in reactions which are involving in terms of an stoichiometric coefficients, how they are expressed? If I take an example, that is AA plus BB giving rise to CC plus DD. Reactions giving terms of an reactants into terms of an products. If I wanted to determine what is the rate of the reaction or the concentration changes. So, changes in concentration, it is given by as an expression, it is equivalent to minus 1 by A into derivative of concentration A, that is equal to minus 1 by B into derivative of the concentration of the B, that is equal to, always because it is represented in terms of a loss, because loss means here it is gaining something. The accumulation instead of decrease, here it is increasing. What it is? Here it is decreasing. Electrocoagulation process, exchange of the molecules and all so on. Okay, that is equal to 1 by C into derivative of concentration of C, that is equal to 1 by D into derivative of the concentration of the D. Okay, this is the set of the reactions. Hence, for the stoichiometric coefficient not equal to the rate of the reactions. So, the rate of the reactions, they are not the same. Rate of reactions, they are not same. If they have to be same means, then they would have been the concentration of A by with respect to the time would have been B. But what is this term 1 by A or 1 by B or here? It mainly represented in terms of an concentration. Therefore, whatever in the general notations, R is always given by 1 by concentration of the I number of the terms and derivative of the concentration of the substances. This is the expression normally given by, and 1 by Ci it is negative for the reactants and positive for the products, which implies that 1 by Ci, if you take the matrix, this it is negative for the reactants because there is a loss, and positive where is a gain into the products, that is for the products. Understanding the concepts of the reaction kinetics. Now with this, let me go for taking the reaction order, how to determine whether they are the first order, second order. I'll go for taking it. It implies for the first as well as the second order type of the reactions. Okay, now let me take upon for the zero order type of the reactions. What are those? Where change, yes, in this part of the session, let us get to know the derivation of the first order kind as well as the zero order type of the reaction. Before moving on to the zero as well as the first order type of the reaction, I think you people have gone through the concepts related to the reaction, means the place or the origin of the changes or the transformation of the products taking place due to the loss of the reactants or the reactants getting transformed into the products. If the reactants are getting transformed into the products, so what is the kind of an equation, whether it is like following a constant rate or maybe it is a changing rate. Let us get to know that particular set of an equation in this part of the session. In the reaction kinetics, we have the homogeneous or maybe the heterogeneous type of the reactions, and based upon that, what are the different types or the typical aeration process or maybe gas interface process, radioactive decay or maybe the BOD exertion process. These are the particular examples related to the phenomena of the reaction. Mainly, I would like to quote here what are the different types of the process that likely to take place. Either it may be adsorption process or bulk transport that taking place in the absorption techniques, and transport phenomena is not only limited in the adsorption process but is also entitled in the case of the air stripping process of an ammonia, advanced oxidation process, and what we call it as the ion exchange process or the membrane filtration process. There also the law is mainly gone by the fixed law of diffusion. Usually whatever the mass balance reaction, let us get to know the mass balance reaction or the equation. We know that the concentration is equal to mass by volume, and please do note that the weight, that is the load that is taking place with respect to the time, is also equivalent to the discharge as well as even the concentration across the particular medium. For example, the reaction taking place in a reactors means reactor, it is a system boundary where the reaction is taking place. Okay. This particular thing we call it as a system boundary. System boundary. Similarly, the equation that is dm by dt, or which implies that here mass is equal to concentration in terms of a volume, where volume is replaced. If you know that V is equal to Q into T, what happens? Mass is equal to C into Q into T. So mass with respect to the time is equal to C into Q. Similarly, that is applied here. Okay. So if you wanted to take with respect to multiply with respect to the time itself only, so what is the consideration? It is with respect to the time itself only. Q is also. And if you wanted to check across what is the kg per second or maybe time or maybe in terms of an gram per second or anything is the unit related to this. That is, we call it as a mass loading concentration. So therefore, dm by dt is equal to what? Volume is a constant, m is equal to c into v. So derivative of c into v, when volume is taken as a constant for the reactor, therefore take it out v, which implies that v into dc by dt. And the reaction rate is normally represented as K, which we call it as a kinetic constant, and C normally. If C is not there, we call it as C power something, okay, C power n, Kc power n. This is the normal with respect to the given volume. Now, let us take the order of the reaction, where order of the reaction it is zero order reaction. Zero order reaction. What is meant by zero order? A reaction is said to be of the zero order if the rate of change of concentration with respect to the time remains a constant. If rate of change of concentration with respect to the time remains a constant. So change of concentration with respect to the time is always a constant. And it may be represented either in terms of minus k, that's all. Minus k means though the reaction has converted in terms of end product, it is at a constant rate. And whatever the reasons in a steady state condition, what happens? dc by dt will be equal to 0. But under the non-steady state conditions and all, dc by dt is equal to minus k. Now let us get to know how to solve the equation. When the change of concentration with respect to time is remaining as a constant, therefore, in this particular differential equation, let us get to know by the separation of the variables, dc is equal to minus k into dt. Initially, the concentration of the substances is not completely in a zero condition. It is only in the case of like a distilled water or any other things. If you check some of the trace elements and all, they will be like a zero in nature. Okay, that is a one process. Whereas, if you check what is the initial concentration of any of the liquid or maybe of the solid concentration, they have some initial concentration. Therefore, you need to integrate by the method of the separation of the variables at certain particular instance of the time. When time t is equal to 0, c is designated to be c naught. When time reaches to the particular interval t itself only, c will be equal to c. Okay, integrating on both the sides, so integral c naught to c, okay, of dc is equal to minus k, remove the constant outside, apply the integration, so 0 to t of dt. So integration of c is nothing but the limit c naught to c, that is equal to minus k with respect to the limit 0 to t. So c minus c naught is equal to minus k into t minus 0, which implies that c minus c naught is equal to minus kt. Minus kt. If I wanted to take the c value, to determine the c value, what I can do? So c is equal to c naught minus kt. This is the expression related to the zero order kinetic reaction, the solution for the differential equation. The zero order type of the reaction where it is applicable, applicability is when concentration is large. When concentration is large in number or in nature, this critical parameter does not accounts for any second order or any other things. Maybe over a frequent intervals of the time, if it is checked, then we shall get to know whether the reaction has a huge concentration or the less concentration. That follows the first order. Whenever a graph is plotted, whenever a graph is completely plotted, whatever the changes that you're going to see, it is taking place in this form with a slope giving a negative value, that we call it as k. Okay, so slope is equal to minus k, where the C naught will be the concentration at this particular instance or the interval of this time, where the concentration changes with respect to the timing condition. Okay, where T is acting in this direction. This is the equation where we go for applying for the zero order type of the reaction. Normally, the zero order type of the reaction, it is applicable when the concentration is very much large in nature and difficult to identify. That's why it remains as a constant. It doesn't tend to changes. So this part of an applicability you can see in the case of the constant flow type of the reactors in a completely mixed type of the systems, which are not tend to decay over a large period of the time. Okay, this is one thing. Now let us get to know. It is also represented as RC is equal to dC by dt. Where the rate of change of concentration with respect to the time varies. Okay, the concentration varies with respect to the change of concentration in the time, and normally it is proportional to the concentration. Okay, the change of concentration with respect to the time is proportional to the concentration at that intervals of the time. So dC by dt is equal to minus k into C. Why minus k we are taking? Either we can take the rate of formation minus rate of loss. If you consider here the mass balance equation, system input minus, so system input minus output plus or minus rate of concentration. If there is no input, okay, that is the discharge is 0 in both the cases. Only thing appears here in the case of the batch type of the reactor, it is much applicable, and even for the continuous type also, where there is no flow. So Q is not there. Okay, this particular formation we call it as rate of formation minus rate of loss, whereas rate of loss is considered. That's why we come across getting this equation. Now here dC by dt is equal to minus kc. Similarly here also you need to integrate the differential equation by the method of separation of variables. This is the first order differential equation, and again here when time t is equal to 0, the concentration of the substance will be equal to the initial phase of the concentration. When the time reaches t is equal to capital T or small t itself only, C will tend to become the original concentration, or maybe the concentration left at that particular instance of a time which is remaining. This set of an equation is much more widely adopted in the case of the wastewater treatment. Now let us get to know by the method of separation of variables. So dC by C is equal to minus k into dt. You integrate by this method of separation of the variables. By the method of, so therefore integration of C naught to C dC by C is equal to minus k into 0 to t dt. Integration of dC by C, or it is similar of the form integral dx by x is equal to log x plus c. Okay, same thing here. So logarithm to base e of C naught and C is equal to minus k into t minus 0. There is a solution, you're going to get it. Now, logarithm to base e of C minus logarithm to base e of C naught is equal to minus kt. This is a log representation. There, how the transformations of the reaction taking place either in the natural part of the systems or maybe in the artificial phase of the systems also. Okay, after seeing that picture, come across for solving the remaining portions of an equation, that is logarithm of C by C naught, I can take it, is equal to minus kt, which implies I wanted to determine the concentration of C by C naught. So C by C naught is equal to e power minus kt, which implies that C is equal to C naught into exponential of minus kt, or it can also be represented as in some of the textbook exponential of minus kt. This is the solution for the first order reaction. Normally, this graph is mainly plotted if you wanted to have the graphical representation, how the concentration changes with respect to the time ln of C by C naught with respect to the changes in the concentration. Y is equal to mx, like they're passing through the straight line, and you have a slope, so therefore slope is equal to minus k. Slope C by C naught, otherwise it will take it as minus k. Getting the point clear? If it is taken in terms of an minus of ln of C by C naught, or in the other cases similarly it is taken as slope is equal to minus k if it is taken in terms of ln of C by C naught with respect to the time. Okay, so this kind of an equation is applicable for most set of the reactions. What kind of the reactions that takes place? Normally, if you consider in the formation of the products, maybe the bacterial action or the conversion, these are the applications. Second one, in the continuous, that is maybe the plug flow, or maybe in the completely mixed type of the system. Okay, plug flow or completely mixed type of the system, and even the disinfection process, in the water treatment, the BOD exertion, natural process of the decay, all these things has the application of first order kinetics. Okay, please do remember, it is very much important for the next particular set of the problems to be solved is mainly based upon this. And this kind of the substances where the natural process of the decay or natural decay, we call it as a non-conservative substances. Non-conservative substances. What is the example of a non-conservative substances? We call it as a putrescible organic matter, rottening of the fruit are all the examples, or maybe the decay of the dead portion of the animals. They are the example which tends to follow the first order kinetics. When the reaction is determined by the aid of knowing the concentration of the initial phase of the substances, there we can go for the application of the first order type of the reaction. Okay, and it is very much important in the case of the BOD exertion, how it is taking place. I will call it as an ln, and even for the nitrate formations or the bacterial conversions that takes place in the wastewater treatment is far more compliable in the treatment of secondary part of the wastewater, or we call it as a secondary wastewater treatment or biological treatment, as well as tertiary treatment also. This tertiary treatment also, it implies even the natural process of decay, disinfection process, and kinetics. Much more advanced version we have, or the studies that has imparted in the research work, is mainly the plant uptake kinetics. We call it as plant nutrient uptake or maybe pollutant uptake kinetics. So these are the phenomena which we tend to observe in the case of the first order reaction. Hope so you people have understood what is meant by first order type of the reaction, where the rate of change of concentration is proportional to the rate of change of concentration with respect to time is proportional to the concentration at that instance of a time, and if you remove it, you have the K as a constant. We call it as a first order kinetic coefficient, and with respect to the time we have integrated it, getting the equation that is C is equal to C naught into exponential of minus KT. In some other part of the textbooks and all, instead of taking the exponential, they go for taking up the 10 raised to the power of, that is logarithm to base 10 instead of the base E. This particular instances of formations of the solutions tends to depends upon how we are going to use it. Similarly, here if I wanted to get to know that time is also expressed in terms of an distance as well as the velocity, please do remember it. So we have t is equal to distance by velocity, distance by velocity. Now if I don't know the time, through the aid of the distance or the velocity, especially this is applicable more in the river condition, okay, in the river condition where we call it as an upstream flow as well as the downstream. What is the initial concentration, how the concentration can be measured at different distances. So totally it is a x, you can call it as like x1, x2 or something and all, like 1 kilometer stretch or 2 kilometer stretch, 3 kilometer stretch and all. And what is the velocity of the flow? Maybe it is like in 2 meter per second. Definitely you can determine it. So this equation becomes C is also equal to C naught into exponential of minus k into x divided by u. This particular set of equations can be given also, okay, and it is mainly applicable in the flow conditions, that too in the plug flow type of the reactors. We call it as in the case of the river. Please do bear it in the mind. The plug flow type of the reactor, or what is meant by that, we shall discuss it. Means whatever this portion of the water is entering, it is also living at the same series, and that coefficient we call it as a longitudinal dispersion coefficient, where dispersion is slightly suppressed and advection is dominated. What is meant by advection? The phenomena of transport of the fluid due to the bulk fluid motion. Okay, we call it as the advection phenomena. We have a diffusion, that is reaction of the transformation taking place with respect to the region of higher concentration to the region of lower concentration, or a migration of a concentration in response to concentration gradient. We call it as in diffusion. There are many set of equations. We call it as either a partial differential equations which are represented by the fixed law first and as well as the second law for the material balance analysis. It is not there for you people, only this is given for in the frame of the syllabus and all. If you people who are interested to have the modeling of the reactors and all, you can approach, so we can have a project also related to that. Okay. So with this, let me cover up or the wind up the part of the first order kinetics and all, and in the next class we shall take up the second order kinetics and determining the rate of the reactions and all. Still then stay tuned for it. Thank you one and all.